Dear friends, today we'll be going ahead and looking into the topic of Flynns Taxonomy. So, Flynns Taxonomy is a categorization of forms of parallel computing or parallel computation. From the viewpoint, the assembly programmer, parallel computers are classified using concurrency in programs, sequences, data, and instructions. So you are performing the multiple operations simultaneously when it comes to Flynns taxonomy. Now, Flynns taxonomy has been further divided into the SIMD, MIMD, and so on, which we'll be going ahead and looking into this topic. Flynns taxonomy has basically two concepts: parallel in instruction data stream and parallelism in the data stream as well as instruction stream. And CPU system has n programs which needs to be executed simultaneously, and these programs are executed in the form of instruction stream that can be executed parallelly. So n instructions running simultaneously so that we get the desired output and result. A data stream can be used as a sequence of data where it has four possible combinations which are being connected to it. So what are those four possible combinations? Now your entire data has been divided into two types. One is called as data and the second is called as instruction. Now when you have single instruction, single data, it is called as unique processor system. It is called as SISD. When you have single instruction, multiple data, it is called as SIMD. That is called as pipeline vector processors. Then you have multiple instruction, multiple data. It is called as systolic arrays. Then you have MIMD, that is multiple processors, multiple data. It is called as MIMD, and that is a part of your multi-processor, multi-core computing systems which are existing and which are taking place into the system. Now let us go ahead and look at this architecture one by one, that is SIMD, SISD, and so on. Now Flynns classification is divided into the different instruction set which are connected to it, different data streams that are connected to it, what will be the different types of operation that will be going on, and the different example. So if you have a single instruction, single data stream, it is called as SISD. The example is von Neumann machine. If you have a single instruction, multiple data stream, it is called as SIMD. Vector supercomputer is an example of instruction set and data streams. If you have multiple instruction set and single data, it is called as MISD. And the example is arguably none. If you have multiple instruction, multiple data stream, it is called as MIMD, multiprocessor and multi-computers which are executed simultaneously. Now let us go ahead and understand what do you understand by SISD, single instruction, single data. Now as the name suggests, it will do only one job at a time from start to finish. Now single instruction, single data, SISD is a computer architecture in which a single unicore processor executes a single instruction stream to operate on data stored in a single memory. This corresponds to the von Neumann architecture. Now, if you look at the diagram, it has a control unit, the processor unit, and the memory unit. The control unit is being connected to the processor in a unidirectional form, and the processor unit is being connected in a bidirectional form with the memory unit. Now, memory unit gives the instructions to the control unit, and simultaneously, the instruction is being transferred from control unit to processor unit, and the processor unit uses the data stream to connect between the processor unit and the memory unit that are being interconnected with each other. But the only drawback is that it can perform only single instruction at a time. Multiple instructions are not possible. Now, single instruction, multiple data. Now, single control unit has multiple P's. Now, what do you understand by PE? It is called as portable equipments which are being connected to it. Now, first let us understand what does single instruction multiple data does. Single instruction multiple data is a class of parallel computers. In Flynns taxonomy, it describes computer with multiple processing elements that perform the same operation on multiple data points simultaneously. So the same operation is performed on multiple data points simultaneously. So single control unit has multiple portable equipments. Control unit fetches an instruction from memory and after decoding broadcast the control signal to all the portable equipment which we call as PEs. That is, at a given time all PEs are synchronously executing the same. So all the portable equipments are executing the instructions simultaneously at the same time. Instructions but on different set of data, hence it is called as your SIMD. So here the instruction is getting executed, but it is getting executed in the different sets of data. That is the reason it is called as your SIMD. So this is the architecture of a SIMD processor. Now when you look at this, it has a control unit which is connected to the processor unit, and the processor unit is being connected to the memory. Now the bidirectional, the data stream flows from the processor unit to the memory simultaneously, but in a unidirectional form, it is being connected to the control unit to the processor unit. Now control unit and the memory unit are being interlinked with each other, and they are processing the instructions simultaneously. Now you have multiple instruction single data. Now what do you understand by multiple instruction single data? It is a type of parallel processing system where multiple functions unit perform different operations in the same data. Pipeline architecture belongs to this type. Though a purist might say that data is different after processing by each stage in the pipeline. So it is performing the multiple instruction single data, but it is being executed simultaneously. So it is basically a very rare type since the data throughput is limited. So you have multiple control units, you have multiple processors, you have multiple memories that are being interconnected with each other, and the processor units are being connected simultaneously. And this is how the processor unit is linked with the memory unit for carrying out the data of data stream, which is connected with the help of the instruction stream to the control unit. So this is how this cycle keeps on repeating, and which is becomes a part of your MISD, multiple instruction single data. Then you have MIMD, so that is called as your multiple instructions multiple data. It is a thorough true multiprocessor system. Now it is a technique employed to achieve parallelism. Machines using MIMD have a number of processors that function asynchronously and independently. At any time, different processors may execute different instructions on different types of data. So multiprocessing, multitasking is being possible because of MIMD. In contrast to SIMD, MIMD is a great purpose machine. When all the processors in MIMD are running the same program, we call it as a single instruction multiple data. That is called as SPMD, because when all the processors are executing the same program but on different data streams, so it is SPMD. SPMD model is widely used by many parallel platforms. So this is a small example with the block diagram of a MIMD processor. You have different control units which are connected to the processor line, and they are being connected to the memory module. The data stream flows between the processor unit and the memory module in a unidirectional form, and control unit is being connected to the processor unit for carrying out the instruction. It is in a bidirectional form, and all of these units, that memory module is being connected to the control unit simultaneously, and the instruction gets executed to be processed. So Flynns classification plays an important role because of these processors, that is SIMD, SISD, MISD, and MIMD.